Okay, let's take a quick look at this. So this is all about operations with matrices, adding and subtracting them, scalar multiplication and matrix multiplication. I think that pretty much covers the topics there. So what type of letters do we normally use to represent matrices? Uppercase, capitals. Okay. What type of brackets do we use to denote that the numbers are arranged in a matrix? Square brackets, right? Not round ones, square ones. Okay. So if I put numbers in square brackets, that means I've got a matrix. They're organized in a matrix. Under what conditions can two matrices be equal? Okay, the entries have to be equal and the order has to be equal. So I like saying same dimensions. Okay, I like dimensions rather, I learned dimensions rather than order. So same dimensions, same entries. And I say it this way. I say same entries, element by element. So you go through and you check each one. You check the first row, first column here. Does it match up with the first row, first column there? Check the second row, first column here. Does it match up with the second one there? It's pretty easy to tell. Can you add two matrices that have different dimensions? Nope, because this stuff doesn't line up, right? Okay. Can you add or subtract matrices? If you can add or subtract matrices, how do you do it? I say add or subtract. I say it this way, element by element. So you just match them up and either add them or subtract them. What is a scalar? What is it? A number. Okay, I'm going to say it this way. It's a plain old number. It's not an element in a matrix, it's just a scalar. If it's not in a matrix, if a number is in a matrix, we call it an element or an entry. Okay, if it's not in a matrix, then we call it a scalar. It's a way to differentiate between the numbers in a matrix and the numbers that are not in a matrix. Okay, how do you perform scalar multiplication? Scalar multiplication. Scalar, we could use a word that they probably don't use, but we could all understand what we mean here.
You multiply the scalar by all entries.
You multiply the scalar by all the entries. It's kind of like distributing in, okay? It's kind of like distributing. Okay? So if I had 7 times this matrix here, I'd end up with 7, 14, 21, and 28. It's kind of like just distributing, right? Okay? Is matrix addition commutative? Yes, it is. Okay? If you can add them in one order, you can switch them around and you can still add them. What about matrix subtraction? Nope, doesn't work that way. Okay, how do you solve the following matrix equation? Okay, 3x plus the matrix A equals the matrix B. So first of all, if I do 3 times some matrix and I add it to the matrix A, which is 1, negative 2, 0, 3, and I get this matrix right here, negative 3, 4, 2, 1. If this is a 2 by 2 and that's a 2 by 2, what does the matrix X have to be? It's got to be a 2 by 2, right? They all have to be 2 by 2s if I'm going to be adding them and subtracting them together, right? So I could call this one x1, x2, x3, and x4 if I wanted to. Or you could say x, y, z, and w or something like that. Doesn't matter, whatever choice you want to use, okay? And then I'd have to do 3 times x1 plus 1 would have to equal negative 3. I'd have 4 little linear equations to solve. Does that make sense? Everybody good there? Okay. And then, I mean, there are a couple other ways you could think of it, but that might be the most straightforward way to do it. Okay. Is matrix multiplication more complicated than scalar multiplication? Yes, by quite a ways. Okay. So here's, and it sounds like most of you got this figured out. Here's what you have to check. Okay. You have to check that the dimensions match up. So if this is a 2 by 2 and this is a 2 by 1, this is the way I like to say it. The inner dimensions have to be the same. I say the inner dimensions have to be the same. So a lot of times I'll put a little circle around these guys right here. and then the outer dimensions are the dimensions of what we call the resultant. So if I take a 2 by 2 and multiply it by a 2 by 1, I can multiply them because the inner dimensions are the same, and those outer dimensions are the dimensions of the resultant. So the resultant is a 2 by 1, and I like drawing it like this. 2 rows, 1 column, and sometimes I'll even put in little blanks for, well, I've got to find these 2 elements. So how do I find this entry right here? Need some help? I swear I heard some people saying they had this figured out. Okay, in fact, I heard some people saying some really cool things of, no, we can't multiply those together, and here's why. Okay, so here's the way I like to do it. Okay, once you know you can multiply these, I do what I call the karate chop method. I'm going to karate chop this one right here with that one right there. And the reason I say karate chop, I'm going to take this row and multiply it with that column. This row with that column. So see where my fingers are and see what matches up? That 1 matches up with that 1. We multiply the 2 of those together. This 4 matches up with that -2. We multiply those together. And then we just add all of those little multiplication problems. So if I do that on this problem right here, I get 1 times 1, and I get 4 times -2. I get a 1 minus 8, so what's my answer? -7 is the number that goes right there. Now, let me go over that again. The reason I took this row and multiplied it by this column is because this entry right here is in the first row, first column. That's why it's important to know where the entry is. That's why on the test you had that little A12 that I wanted you to find. A12 is in the first row, second column. This one right here is in the first row, first column. So I take the first row here and I multiply it by the first column right here. So 1 and 1, 4 and -2. 1 minus 8 is -7. Where is this one right here? Second row, first column. So I'm going to take the second row and multiply it by the first column. And things are going to match up. If you do that right-hand karate chop thing, it matches up. So I get -3 times the 1. I get 0 times the -2. So I get -3 and 0. What's the number that goes right here? -3. Any questions there? Okay. Is matrix multiplication commutative? Can I move it around? That's the answer to question 12 right here. I can't, because if I were to take the 2 of these and I tried to do a 2 by 1 by a 2 by 2, are the inner dimensions the same? Nope. So you can't multiply them. Okay? You with me? All right, let's take a look at this one right here. This is a 2 by 2. This is a 2 by 3. Can I multiply these together? Yes. What are the dimensions of the resultant going to be? They're going to be a 2 by 3, right? So let me make this a little bit bigger so we can see what's going on here. Whoops. Not quite that far. So here's what I've got. I end up with a 2 by 3. So 2 rows and 3 columns. So I have 6 elements that I need to find. I've got 6 blanks there. Okay, watch please. Find this number right here. This one is in the first row, first column. I'm not going to do all of these, but we'll do a couple of these. Find that number right there. Don't say anything out loud, just write it down. If you've already got it written down, hopefully you get it right. Double check your work. This entry is in the first row, first column. So I'm going to take the first row and multiply it by the first column. That's going to be a 2 times a 1 and a 4 times a 0. That's good news because the 4 times 0 is 0. What number do I put right here? I put a 2. Watch, please. Where is this one? Find that entry right there. This one right here. It is in the second row, second column. So I'm going to take the second row and multiply it by the second column. So that's a 1 times a -1, a 1 times a 2. So that's -1 plus 2. So what's the number that goes right here? It's a 1. Okay? Find this one right here. Figure out where it is. And once you figure out where it is, you know the things you've got to multiply together. This is in the What row? It's always rows then columns, right? What row is this in? First row, what column? Third column. So I'm going to take the first row and multiply it by the third column. So I've got the 1 times the 0, and then I've got the 1 times the 5. So I get? What?
First row.
Oh, first row. Oh, thank you very much. So I highlighted the wrong one. So 0 here, and then, so it is 20. Thank you very much. Okay? I'm zoning out. Everybody good there? Okay. Let's see. Let's take a look here. Did you have a problem with one in particular? Or do you get it now? What? What do you mean? You good? Okay. Can these be multiplied? Nope. 2 by 1, 2 by 2. Whoops. Can't be multiplied. Can these be multiplied? Yes, they can. This is a 2 by 3 and this is a 3 by 3. Inner dimensions are the same, so the resultant is going to be a 2 by 3. Again, I like writing it and then just putting in how many blanks I've got to fill in, and then I go from there. Okay, any questions there? Okay, almost done. Watch, please. Okay. These two problems right here are exactly the same, but they're in a different order. Can somebody explain to me why these can be multiplied and these can't? I heard a couple people talking about why it would work in one case and why it wouldn't work in another. Okay, see how the number of columns here? I've got a 1 and a 4 here, right? So if I multiply it with this column right here, the 1 matches up with the 1 and the 4 matches up with the -2. Let's try that over here. Take the first row here and try and multiply it by the first column. What happens? The 1 matches up with the 1, and then what does the -3 match up with? Doesn't have anything to match up with, right? Okay. Here I've got 3 columns, 3 numbers in this first row right here. And if I match it up with these 3 right here, that's why that's important, that the number of columns in the first one matches up with the number of rows in the second one. So each one has something to be multiplied by, and then we add them together. Good there? Okay, all right, there's the assignment right there. Okay, those problems. If you have it done tomorrow when you come to class, that's awesome. Maybe leave a couple that you can work on. We're going to spend a little bit of time tomorrow introducing 8-4, and then we'll finish up 8-4 on Friday. And so hopefully we'll finish 8-4 about halfway through class on Friday. You can work on 8-4 in class on Friday, get a little bit of that in your head, kind of get it cooking, and then we'll remind you of that on the Monday when you come back from spring break. Okay? Good plan? Okay, all right.